Hello, I think that we can start, and let me welcome you all at the beginning of this session. For some of us it is afternoon, but I think for all of us it's Friday, so we have 1 week of conference behind us and a lot of very interesting topics here. And today we will have opportunity to first listen and then, of course, to discuss with Ben Mestel the topic mathematics e-assessment at the Open University. It's kind of an overview, as far as I understand, Ben, of what have been done and how mathematics e-assessment has been performed at an Open University. And after that, you will have opportunity to ask questions. Please ask questions in Moodle, so it can be revisited later, and Ben can answer if there are some questions that we are not going to answer here during the session. And after this first part, we will have opportunity to discuss a little bit more. If there are some questions or some comments from you at the end of this week. So this is roughly the very simple schedule for today session. So let me ask Ben to start, and Ben, please take your time, and after that we will have chance to ask questions and comment.
Okay, well, thank you very much. And thank you very much to the organizers for giving me the opportunity to speak this afternoon. It's a Friday, as you mentioned, and it's quite hot here in the United Kingdom. And so I hope you've got good weather where you are as well. So I'm from the Open University, which is the principal distance learning university in the United Kingdom. It's a very big university in terms of the number of students, but most of our students are part-time. And I've been at the Open University since late 2006, and I've been there during an exciting time when we've been developing e-assessment. And I'm going to give an overview of the work that we've done, and I hope it will be interesting for you. So it's a little bit of a nostalgia trip because I'll be showing you some of the early work that was done, and then I'll be showing you what the current state of play is. Because since we started the work a long time ago now, the growth in e-assessment at the Open University has been phenomenal, as you will see. Okay, so let me move on, and that's right, that's fine. Okay, so the Open University opened in 1969, and that was the beginning of the period of objective testing by computer. And when I was a school child, actually, I did, as part of my exams, my A-levels, I had objective testing. I remember filling out grids like the one you see. And of course, the Open University, being a new modern university, adopted these types of assessment quite early on. And one of the interesting things is that we've kept doing this sort of thing. So the grid that you see in front of you was actually used up until the pandemic. Students would sit in an exam hall, and part of the examination would be written and part would be done by filling out one of these grids, would be a multiple choice objective assessment test. So you can see we have still got vestiges of the old way of doing things. Whether that will be true after the pandemic abates, I don't know. So I'm going to talk about the Mathematics Online team. So when I came to the Open University in 2006, I joined and indeed led a project for developing all sorts of delivery and testing of mathematics online. Because although the Open University had used computers, as I indicated, for a long time, certainly in the mathematical sciences, it had been less innovative, I think, in terms of using the internet as a means of both of delivering teaching, but also in terms of assessing students. And these are a group of people who worked on the the project while it was started for 3 years. Tim Lowe, you may know, he is quite involved in e-assessment. Indeed, I think has talked at one of these conferences before. I'm there at the back, but also two of my colleagues, Gaynor and Camilla, they both now retired, in fact. In fact, a number of the people in this list are no longer working at the Open University. But there were also many AL colleagues. So I should explain, AL stands for Associate Lecturer, which is what the Open University calls the part-time tutors that teach on a day-to-day basis. So the Mathematics Online project was a 3-year project. It was based in the Mathematics and Statistics School, but worked with OU colleagues throughout the science, technology, and computing areas. We worked with the Settles. Now, maybe some people know about this, but at that time, there were centers of excellence in teaching and learning. There were 2 particularly that we worked with at the Open University. I've written them there. But there were also others within the United Kingdom. I remember there was one in Coventry, Sigma, which we also had connections with. So we principally focused on delivering mathematics teaching, and not just mathematics teaching. It was also any symbolically rich discipline, which could in principle include music, for example. But we principally focused on the question of online tutorials, on digital marking, which is a big thing because there were lots of student assignments that had to be marked, and also on e-assessment. And it's the last one that I'm going to talk about today. We also touched on other subjects. We considered the question of conversion of legacy material before LaTeX had been used, and also learning objects and that sort of thing. So let me show you some early e-assessment, because when we arrived at the Open University, I have to say that there had been a very good tradition of innovation in e-assessment. In particular, the Open University had developed the open mark system, which an example you see in front of you. Obviously, it's not in mathematics. It's in geology, and it's asking students whether they can identify what an igneous rock is. This was a bespoke system, but the Open University developed, but it was unfortunately quite hard to implement by users because it required professional programming. So if you wanted something to be done, by and large, you had to get a professional programmer to do the actual implementation, which meant, of course, not only did it take a long time, but it was very expensive to develop. Nevertheless, it was very innovative of its time. Of course, this particular question, could you identify igneous rocks? They obviously used some form of parsing to determine what the student wrote, whether it was correct. And I often say, well, did they always get it right? So if I'd written as a student, I don't know, but certainly not in volcanoes, I suspect that they would have given me full marks for just using the word volcanoes in my answer, because, of course, it's very hard to parse natural language and to decide precisely what it's saying. But nevertheless, it's very innovative, and Phil Butcher was particularly important in the development of OpenMark. OpenMark, which is available, by the way, although it's going to be taken out of commission soon, is still used today. This is an example of what we call an "Are you ready for?" quiz. So we have at the Open University more or less open entry at the undergraduate level. So a lot of our students come and they need to brush up at the very least their mathematics. So many of our modules have these quizzes where students can answer questions to determine whether they're ready in their preparation to take that module. And this is one for a level 1 module, MST 125, doesn't matter what it means. But the point is that you can see it, that this is done in OpenMark. You can see the OpenMark logo in the bottom right. And it's not very sophisticated in this particular question. You obviously just had to put in an integer or a fraction and it would give you yes or no. Actually, it would provide feedback. I'll show you a little bit of some of the feedback that was provided at that time. But you can see it is nevertheless quite attractive. And one of the great things about the Open University is that there's a lot of work goes into not just the technical aspects, but in the visual design. And at that time, this was a state of the art for the visual design for this type of thing, I believe. So we still use it today. Here's another example of obviously a graph, and you have to work out the integral and then put the number in. And here's another one, which is drag and drop. So drag and drop, of course, is very common, but again, it was perhaps less common at that time. And this was also a capability of OpenMark. So one of the great things, I think, is that we realized that if we were going to make e-assessment a real strength of the Open University, we have to move beyond OpenMark. Because OpenMark was simply too hard to develop. It had a lot of good capabilities and was attractive, but nonetheless, just simply wouldn't scale up in the way we wanted it to, in terms of the number of questions that we wanted to develop. So there were lots of explorations at that time. And so I've listed some of the people who were involved. And I want to just go through a sort of celebration, if you like, of the work they did at that time. They did it in Moodle, they did it in OpenMark, and they did it in the stack system. So I'm just going to gently go through them and celebrate their work. Obviously, they're all, this is work from 15 or more years ago. And so some of it is, of course, dated. Of course, you'd expect that. But nevertheless, this gives you an idea of the sort of things that were done. One of the things we were keen on at that time was to provide tailor-made feedback for students. So if students gave a wrong answer, we would not just tell them they were wrong. We would tell them, give them a hint why they were wrong and what they could do to get it right next time. So as you can see, the feedback here is tailor-made to the answer that the student has provided. And this was done by a colleague of mine, Judy Eakins, who has indeed since retired as well. But the feedback's pretty rudimentary. We could do a bit better than that. Another thing is that the Open University has, as I said, a quite wide range of people who come in to study, having open entry at the bottom level. And so there are a lot of people, particularly not necessarily in science, but elsewhere, who have pretty rudimentary mathematical skills. And this particular example was simply designed to help people practice their knowledge of fractions. Which of course the mathematicians by and large did not need, I'm glad to say, but nonetheless other students within the university benefited. And again, you can see the emphasis is on providing tailor-made feedback. This was actually produced by Sally Jordan, who's actually a physicist, in fact, not a mathematician. We did have some very interesting innovation at the time. This is in physical chemistry, actually. It's much higher level, of course, than the one I showed you just now. This is a problem in reaction kinetics, actually, and it's really quite sophisticated as a problem in itself. Actually, it shows you what we were doing in terms of innovation more generally in the sciences at that time. And Christine Leach was indeed a chemist. Finally, I'll show you Tim Lowe. This is, of course, the stack system as it looked at the time. It looks rather quaint now, actually. We're looking back, but of course, style changes, doesn't it? And this was one of Tim's early successors in using the stack system. Since then, he's done a lot of questions. This particular student, I don't think is particularly good, doesn't know how to solve this simple ordinary differential equation, which isn't really an ordinary differential equation at all. It's simply an exercise in integration. But nevertheless, this student hasn't done very well, but there was a lot of, perhaps a bit too much feedback is given in this case. I don't know what you think. But nevertheless, it shows the sort of things that we were doing at the time. So it was very interesting to look back and see the sort of work that was done. So when we were in the Mathematics Online project, we had to decide how the Open University was going to go forward, because we had this very good bespoke system, the OpenMark system, but nevertheless, it was very hard to develop it because it required professional programming. And there were a number of systems we looked at the time, including numbers from Newcastle University, Dewis from the University of West of England, a system called MathsEG that was called also Mathletics from Brunel, the stack system developed by Chris Sanguin, who at that time was at the University of Birmingham. He's now in Edinburgh. And also Maple TA, which is part of the Maple system that was used, for example, at Portsmouth University. And it was very tough because we had to make decisions as to which of these particular systems we should invest in. And the Open University is very big and a lot of money would be spent. And we had to make sure that what we spent the money on would be successful for us. And it was very hard, which is why I have given a quote here from Shakespeare. This is a quote from Macbeth, where Banquo speaks to the witches. The witches have just promised Macbeth that he will be king, and Banquo turns to the witches and asks them what they can predict for him. And of course, they predict that he won't be king, and indeed he's later murdered by Macbeth, but that his son and his descendants will be kings. So that's what I like this particular quote, but it is illustrative of the difficulty we had at the time of deciding which of these systems to invest in. And I have to say, we also looked at one from Kentucky in the United States as well. That's not listed here. And we did in fact decide on the stack system in the end. But it took us a long time to decide that. And it also took us a long time from around 2008 to actually get Stack up and running and in a fit state to roll out to the students, even because we had to integrate it into our systems, which were Moodle based, by the way, and there was still a lot of work that had to be done. That work was done largely by a guy called Tim Hunt, who I will show you a picture of later on. But it was first used in 2014, and I'm grateful to Tim Lowe for providing me with these slides and this data. But it's mushroomed since then. We currently use Stack in 11 of our mathematics modules and 9 engineering modules, but only 2 of the physics modules. So about 20 modules of our university use Stack. I'm not talking about e-assessment generally, that's much more widely used, but Stack itself is used in about 20 of our modules. So this is a very interesting slide. It gives you an idea of how successful e-assessment has been at the Open University. So the virtual learning environment at the OU is Moodle based, and the OU has actually put in a lot of effort in developing Moodle, helping the international community with Moodle, in fact. But as you can see in the academic year 20 to 21, so that's last year, there were, oh, it's staggering to think, nearly 9 million Moodle questions answered. I mean, it's a significant number. And of that, over 1.5 million were Stack questions. So they essentially were mathematics oriented. They weren't all using the real capabilities of Stack, but nevertheless, there's a significant number of students who are answering questions using one of these e-assessment systems. Of course, you can see here in this diagram that most of the questions were multiple choice, just as the Open University had been using ever since its formation, as I showed you on the first slide. But Stack, nevertheless, comes a good second, I think. And interestingly, although multiple choice wins, multiple choice actually forms about 40% of the database. It consists of multiple choice questions, but only 5% of the database consists of Stack questions. And so if you like, Stack punches above its weight in the Open University. The significant number of Stack questions are actually used by students, even though there aren't that many compared to multiple choice that are actually available to be used. I'm slightly surprised by this diagram because I would have thought the short answer would be used more. It doesn't seem to be. And maybe these are areas that need to be developed further. But we, of course, have concentrated on Stack, although Stack has many features beyond just computer algebra. And so well did Stack do that my colleagues, and I always want to celebrate this, my colleagues at the Open University, Tim Lowe and Tim Hunt, you see there, and Chris Sangwin, the developer of Stack, they were given an award in 2017. At that time, there were 1 million Stack questions used annually. As you can see, since then, we've had a 50%, more than 50% increase in the use of Stack. So it's still growing, and it's a phenomenal success. And when I look back at the initial work that we did in e-assessment, only in 2006 to 2009, if we just look at that period, you know, that's why I quoted from Macbeth, because the growth has been extraordinary, and it's really very impressive indeed. So let me now talk about how we use Stack in actually terms of various areas, various disciplines. And one of the things that we've tried to do is to use Stack in pure mathematics. And here's an example that comes, I think, from a third level module, where you've got, obviously, in group theory, and you've got a group table, and a normal subgroup has been identified, and the cosets are listed there. And students are asked to fill up the group table for the factor group, the quotient group, and then identify which of the two groups of order 4 listed it is. And of course, I don't know if you do the question, I believe the answer is it is actually the Klein 4 group, this particular one. But it gives you an idea of how Stack is used in pure mathematics. Of course, it's not necessarily using all the computer algebra capabilities. And as you can see, students have to choose from a drop-down menu. I haven't given a print, I don't show here, I mean, what they're allowed to choose. They're just, but it's clear they make a choice from a number of available answers. So that gives you an idea of how it's used in pure mathematics, but it's still highly computational, as e-assessment tends to be. And I'll have something to say about that. Here's another example of pure mathematics. This is combinatorics, and counting the number of types of objects shown here. It also shows you how attractive the graphics in Stack has become. And one of the great things, I think, that it was a game changer for me, certainly, in the use of Stack, was the ability to produce graphics, randomized graphics on the fly, in order to produce very attractive questions of this kind that you see in front of you. So that's also the sort of thing we do in pure mathematics. But again, it's counting, it's computation. So it isn't theoretical. And I think that's probably the thing we really need to develop. Of course, it's used elsewhere. Here's an example. Of course, it's natural to use things in stats, in statistics. But the sort of questions, although they are quite theoretical, actually, if you look at them, it's quite a theoretical question in statistics, is asking to understand the nature of a skewed distribution and how the sample mean and the sample median are related. So it's quite a theoretical question, but nevertheless, in terms of the actual mechanisms behind the e-assessment, it's really just sort of multiple choice, if you like, and a simple numerical entry. We also provide Stack for the engineers. I myself have been involved in that, but it's quite successful. The engineers like it, the engineering students like it, but in terms of the mathematical sophistication, it's not very high. As you can see, if you look at this question, it's really just a matter of a bit of trigonometry. That's what's been asked here. But nevertheless, it is very useful for the engineers. And as you saw before, 9 engineering modules use Stack in order to teach mathematics in an applied setting, in an engineering setting to their students. Okay, so my main contribution personally has been to develop Stack at the master's level. And here, for example, is a Stack question from the module I run, which is called the Calculus of Variations and Advanced Calculus. And I don't know if you're familiar with the Calculus of Variations, but one of the principal theorems, a very significant theorem, not just in the Calculus of Variations itself, but in applications in physics, is Noether's theorem. We do some standard exercises in applying Noether's theorem, and we get the students to do it using the STACK e-assessment system. In this case, what the students are asked to find symmetries of this particular functional. So there's the functional written in front of you. It's of a particularly simple algebraic form that enables a symmetry to be found in terms of scale transformations that are written there. It doesn't really matter what the answer is. What's important is that it's something that the students can do to practice on their understanding of Noether's theorem. Once they've got the scale transformation, they then have to find what's known as a one-parameter family of transformations. And from the one-parameter family of transformations, they can get an invariant, what's called a first integral of the system. And that's what they're asked to do. So this is an example of a multi-part question at quite a high level in terms of its mathematical sophistication. But nevertheless, in terms of the algebra, it's not that complicated. One of the problems we've had is developing questions in STACK at the master's level, which are sufficiently algebraically complicated to be of interest, but nevertheless tractable for the students to do. And it is a continuing challenge for us. So once they've got their one parameter family of transformations, they can then find they're asked to find their invariants, their first integral, which they then put in, and then we provide the answer. And one of the things that we don't do so well is provide feedback that is tailored to the student answers. As you saw at the very early stages when they were doing relatively elementary mathematics, there was a lot of emphasis on making sure that the feedback provided was tailored, was specific to the answers the students actually gave. We don't do it in these questions. We provide feedback, we provide hints. So if they get it wrong, we provide the student with a hint. If they get it wrong again, we provide them with even bigger hints. And if they get it wrong a third time, we provide them with the solution, and this is the solution. And you can see it's not too difficult algebraically, but nonetheless, it is something that the students find that they have sometimes difficulty doing until they get the hang of it. So that's what we've been doing. We've been developing STACK at master's level for a number of our modules in the Calculus of Variations, which is an applied mathematics module, but also in some of the pure mathematics modules. We have a couple of modules on analytic number theory, and some of the more computational aspects of those modules have been used with STACK, have been developed for STACK. And we've also got a number of calculations in Galois theory, and we're currently spending a bit of time developing our STACK use for Galois theory being, of course, pure mathematics. So one of our problems, I think, is that our applications in both pure and applied mathematics are inevitably very computational. And I know there has been work done, for example, by Chris Sangwin and co-workers, moving beyond calculation to actually use STACK for proofs. And that's something that I personally will be very interested to see how that's developed and see whether we can use it in the Open University. I have to say that we do have a problem moving out of the pandemic because of the work of the Mathematics Online project at the Open University. When the pandemic struck, we managed to move seamlessly to online delivery, online assessment, because we'd already built up that infrastructure. over the previous 10 years or so. So we'd actually didn't find it very difficult. A lot of universities, certainly within the UK, but I imagine more widely in the world, had to very, very quickly adapt and did it by and large very well. I have to say, I'm an external examiner at a university in the UK, and I've been impressed by how they adapted so quickly to the pandemic. The Open University, and certainly in mathematics, found it relatively simple to adapt because we'd already built up this work that some of which I've been describing to you today. But moving out of the pandemic, we have problems ourselves because we previously had in-person examinations, and it's not clear whether the university as a whole wishes to return to in-person examinations, although by and large mathematicians and other scientists prefer in-person examinations. So we're wondering what role e-assessment can play in the future for us, whether we can move to a growth in e-assessment, not just for formative work, but also for summative work as well, because most of the things I've been describing at the master's level, which is the area I'm most involved in, are in fact formative, they're not summative. So if we need to develop e-assessment for summative purposes at the master's level, we're going to have to think very carefully about whether we are actually testing the right things by these somewhat computational questions that I've shown you today. And a key thing, and I think I'd like to ask your opinion here, actually, something that is concerning us a lot, is this question of academic integrity, the question of how we can make sure that the work that the student provides is in fact the student's work. And not only that, actually, sometimes in the Open University, because it is a distance learning university, we have to worry about whether the student is in fact who they say they are. Sometimes it could be possible for a student to impersonate another person. So we have to worry about things like that. And I just wondered whether e-assessment could help us to a certain extent with some of these issues, partly because we can then adapt our questions to individuals, making sure, of course, that at all stages it's the same level of difficulty for each of the students who take the assessment. So I would like to ask these questions of you. I appreciate I've shown you what we've done, and which has been a big growth industry for us, e-assessment, as I've explained, but we still have many more things we need to do, and developing e-assessment post-pandemic is something that I'm particularly interested in, and I would very much appreciate you as a community, your input into how we might develop e-assessment, both as summative e-assessment, but also in the area where we aren't so strong in, which is in pure mathematics. So let me finish there, and thank you very much for listening. And I don't know quite how you're going to do the questions, but I'm happy to answer questions both now, but if there are questions in Moodle, I'm happy to answer them at a later stage. So thank you. I like this particular picture dating back to the Middle Ages of a woman teaching geometry.
Thank you, Ben. Yeah, for your presentation, but also this very interesting picture you are sharing with us. So now the floor is open for questions. As I said, you can ask questions in Moodle. I just checked a few seconds ago, and there wasn't any question in Moodle. But since we are comfortable with time, you can ask questions here. Writing in chat as well, if you are comfortable with that, even though yeah, we recommend to use Moodle, or to use your mic and voice to comment and ask question. Okay, until we are waiting for you, let me just say that yeah, you're right, Ben, that there are certain challenges that we've been facing during pandemics. One of these challenges is certainly academic integrity, and also how we should provide some kind of a fair e-assessment, not to just give our students what we have, what we prepared in a way that it is easy to be prepared, but what is really relevant. So it means that this validity is important, and also this procedural knowledge and skills, not only the final result. But yeah, Chris.
Thanks, Blanka. Ben, I want to ask you about the in-person exams. This is something that we're sort of thinking about at the moment in Newcastle as well. I'm assuming historically, when students have come in to sit proctored exams, that was on paper. Is that right? Yes. Can you foresee, bearing in mind this idea of partial automatic and partial manual that you talked about there, can you foresee in the future the Open University having in-person PC exams, that students come in and sit a proctored PC exam and sit a stack assessment or some sort of hybrid of stack and something else? Is that something that might happen in the future?
It might, but there are severe logistical problems because the students of the Open University are dispersed geographically, and I'm not just talking within the UK. We have students abroad as well, particularly on our master's program, actually, in mathematics. Because of that, we have to set up these systems all over the country. We'd have to have examination centers, and the overhead in actually setting up a bank of computers, for example, for students to take their exams is phenomenal and would significantly increase the cost to the university. So it's unlikely that we can go down that route unless we can actually use the offices of a third party. So, for example, when my daughter not so long ago took her driving theory test in the UK, she went along to a test centre and took it under controlled conditions. And that's how it's done for the driving test. And I could see a situation arising where students could go along to their local test centre, sit down at a computer, and it would be connected to the Open University e-assessment system, and they would do their assessment like that. But the actual organisation of a whole of students sitting down all together and doing e-assessment questions all together at the same time, I think that's unlikely to be feasible in the future.
Yeah, you mean because of the numbers of students and their because they're geographically quite dispersed, yeah?
Both of those things.
Yeah, because we are using after the actually this first phase during pandemic, when we used then e-assessment as an online assessment. At the same time, students have been, of course, all around and using cameras, but also using personalized tests. So it means that each student got from the data bank their own exercises and tasks to work on. But now we have this kind of hybrid system that Chris mentioned, that we ask our students to bring their own devices, so bring their own devices, and then they can again have this personalized tests on a computer, and they can work their procedures on paper, but type into computer some results and so on. So it means that that actually we try to use the benefits of the e-assessment for quick marking when it's possible, but also to look at the uploaded procedural, notes from them if we are needing. But it is because we have, I don't know, 300 students at the same time, not 3,000. So it's quite different. Yeah.
Yes, it's a matter of scale.
Yeah, that's right. Yeah. That's right. But I think that it can be adapted in a way. But we have here in chat some questions. I don't know, Ben, if you can see it. So it's one from it's actually Frosina. Thank you, Benjamin. It was a great insight of the process, how assignments are used by different programs. Regarding academic integrity, I add a copyright to my own test questions and stress that those are all my intellectual property, and if they are found online, students will be facing academic integrity problems and also stealing my intellectual property. Not sure if this is something already done at the Open University, but it is worth trying.
Yes, can I comment on that? Yes, of course,
yes,
we do that. In fact, it's more or less the only way we can do it, because if a student takes our exam paper and posts it on one of these sites, I won't name their names, and these cheating sites, as I call them, if they do that, then the only recourse against the site the university has is essentially intellectual property. It's the university's intellectual property that have been posted on their site. Of course, if we know which student has done it, then we have other sanctions we can apply to that individual student. But in terms of the actual sites, now that is going to change. My understanding, I'm not completely familiar with what is proposed, but in the United Kingdom, I believe there are plans to make it hard or indeed illegal for these sites to operate so hopefully things will get better, but it is a serious problem, not just for the Open University, but also for all higher education institutions within the UK and also within the world, I guess, too.
That's right, because we've been investing quite a lot of time in developing, and then it can be just if you would like to share, it's fine, but if don't, then and then it's Garrett. Question here, Garrett, you can also ask by yourself, or would you prefer that I read it here? It is upon you.
I'm happy to read it.
Okay.
I guess my question was, it was a really interesting talk, and it's, very clear, VOU have been a real kind of pioneer in this area. And I was just curious to know where maybe, looking ahead for the next kind of few years, the foreseeable future, where you could see things going in terms of online e-assessment, what you think could be the opportunities of new technologies, and where kind of strategically and kind of technically you could see the OU going over the next few years, and more generally what you think the kind of opportunities and new challenges there are.
Okay, so when we first started doing the Mass Online project, we did look on questions of whether things could be done in a miniature way, the idea was, we had in our back of our minds that people would have their mobile phones and they would sit there and they would do their work just on their mobile phone as they commuted to work. After all, most of our students are part-timers. And also they might answer all their assignments using their mobile phone. But in fact, I don't think that's been developed much. I just don't think it's the right technology. Mathematics requires, to a certain extent, some extensivity, if you like, if I can use that word. You need to be able to see things that properly, and you'd spend too much of your time expanding up the screen to make sense of the equations and all this stuff. So one thing I don't think personally we're going to go down the route of is actually miniaturizing a lot of our assessments. We will still expect our students to have some form of PC, or at least a tablet that they can use. So that's the first thing. So I don't think it'll go down that way. What I do think we will do is we will move more to all our assessments being individualized, as was mentioned a minute ago. That's something that does happen, of course, with our e-assessment, but it is a vexed issue when it comes to summative assessment, because we have to make sure that each student gets a question which is of the same order of difficulty. And having looked at various e-assessment questions in the past, I have thought to myself that aspect hasn't been developed sufficiently. Sometimes you see students being given a question with, say, 1 as a coefficient, and sometimes you see people being given questions with, say, 25 as a coefficient, and the difficulty is actually quite significant. Actually, the difference in difficulty is quite significant. Yeah. So I think once we've really, and maybe you can tell me this has now pretty much been solved, but once we made sure that students can get the same level of difficulty for their assessment, then we will be more inclined to use it for summative. Even for for individualizing written exam papers, which was mentioned a minute ago as well. I expect that is what we will do. We will simply be able to produce LaTeX on the fly, which we will then send to students at the appointed hour when they take their online exam, if indeed we continue with online exams as we've had during the pandemic, of course. Students have had to download their exams, but assuming that we can more or less randomize production of a written exam using LaTeX, which of course is totally feasible from a technical viewpoint, but needs to be integrated into our systems. And again, we have to make sure that each exam not only is unique, but is also of the same order of difficulty. But I suspect that's where we'll go down that route. But in fact, one of the reasons for using e-assessment for us may in fact prove to be freeing up staff time. So one approach to the whole question of academic integrity is to ensure that we as staff, and that includes not just the academic staff based at the university in Milton Keynes, but also our network of tutors, the associate lecturers I mentioned before, that all our staff can have a proper relationship with their students, which is hard to do with so many students at the Open University. But if we can free up staff time, and maybe that is indeed the real advantage for us of e-assessment, is that it will free up staff time so that we can then use that staff time to develop proper sort of relationships with our students, rather like the tutorial system that exists in most universities, at least in the UK. And that way we can guarantee to everybody's satisfaction that students are genuinely studying and providing work that is genuinely their own. So maybe I say there are two ways I see it developing. One is individualized assessment of all kinds, but also use of this assessment as a way of ensuring we can focus on individual relationships more than we can possibly do at the moment with the large number of students we have. So that's looking at simply from an Open University perspective. Does that answer your question, Gareth?
Yeah, that was really interesting. Thank you, Ben.
Yeah, maybe just one clarification. When I said individualized out of the data bank, it means that we are organizing our data banks like a matrix. So it means that you have levels of questions and also several levels according to taxonomy and also the topics. So it means that kind of a validation process have been performed, but we have a lot of questions here. So I don't know, it is one even in Moodle, so I would say that it's very interesting topic. So let me see. First, we have a Chris Graham here. Chris, would you like to follow your what you write here, or?
No, it wasn't a question. It's just
okay, yeah, just a comment, please. So Newcastle, we have several cases where students posted their randomized e-assessment questions to one of the after mentioned cheat sites for which the question variables were unique. May as well have put their name on, yeah.
Yes.
Yeah.
Well, there's no accounting for stupidity, as we say in English. Yes.
Yeah. And then Robert put it here. It's also worth investing steganography here. Okay. Okay. And then for Sina, a question to Ben and others: are students asked to do any tests on academic integrity policy prior taking a test to make sure that they read it and understood it and also accept the consequences? Yeah.
I can answer that in the Open University. Please. Yes. So, I mean, in fact, the university has been very, very proactive in making sure students not only understand what is expected of them, but they actually sign up to it. So typically they have to sign something to say that the work is their own, but also our exam papers now, they obviously have the front page, but the next page is a long statement about plagiarism and cheating and all sorts of things, warning the students of all the terrible consequences that might occur if they cheated. So the university has been very good at that. And of course, we have been using increasingly systems such as Turnitin or Copy Catch. These types of things, even for mathematics, we've been using them, and certainly for our project work, just scanning them just to check there hasn't been any wholesale copying of other people's work. So we are doing these things, but nevertheless, it's still a major problem for us, partly because our students are dispersed and there are so many of them. And so we any idea you have would be really welcome, I think.
Yeah. Thank you. I have one question here in Moodle. It's Chris Sanguine. What is the single most important missing something? Let me see what it is. But feature, yeah. But I cannot figure out the context. So Chris, if you would like to join in and.
Well, generally an online assessment, Ben, what do you most want that you don't have?
Well, what I most want, which I won't have ever, is what I started with, which was the question about igneous rocks, which was one of the first ones that I came across at the Open University using the open mark system, which was simply asking whether the student could define what an igneous rock was. I want something that can understand, real natural language and interpret it, and mathematics as well. And if you can provide that for us, Chris, I think we'd all like it. We'd be very, very grateful. So that's ultimately what I'd like to do. Actually, interestingly, when I was working at in the Mathematics Online projects, I did spend too long actually as a little hobby. I developed a system whereby mathematics input in Word using the Word Microsoft Word mathematics system. Whether I developed a sort of automatic checking for equations in Microsoft Word, using a computer algebra backend in order to check that these equations were correct. And of course, it was just a toy, and in no way could it ever be used in reality, because the variety of input that students put in is so good, so large, that even accounting for even the natural variations would be virtually impossible. So I guess that's what I would like. But beyond that, what I would like, and I know, Chris, you've been working on this, I'd like some way to develop e-assessment in pure mathematics, because of my colleagues, I would say it's the pure mathematicians who are most skeptical of this, and rightly so, because a lot of pure mathematics is conceptual, it's not computational. We've developed, computational e-assessments, as I showed you a few minutes ago, but we still really haven't got round the whole question of how you do e-assessment for more conceptual things, including proof.
Well,
so that's really what I want.
Ben, as you will no doubt remember from my Stack Developers update, we have got some quite exciting language processing features which will land on your desk this summer at some point when you update your service and when we release the new version. I mean, these are shorter fragments than any of us might like, but I think it's a step in the right direction, and it fills quite an important gap.
Yeah, well, I'm very pleased to hear that, Chris, because actually, I think that's what we need for this type of thing.
So some colleagues in Germany implemented an algorithm which calculates a metric on strings, and that can be used. And the great thing about that is it has an automatic spell checking component built in. In fact, it's the same algorithm that most of the auto-completes and spell checkers use under the hood. So that means that all the anxieties about being penalized on a technicality for spelling somehow disappear naturally, because they got the algorithm right in the first place.
Well, that's very encouraging.
Yeah, I think that Mark, you would like to say something, because I see that you raise your hand.
Yeah, sure. I just wanted to reflect back on the academic integrity thing again. Is just made a really interesting comment about how one mitigation for ensuring academic integrity is building that personal relationship. That's sort of it's a nice sounding mitigation that you don't hear very often as one of the things that people might do. I guess I still worry, like probably most people do, that how do you prevent somebody else sitting at a computer pretending to be the other person? Like you could hire a friend and say, oh, here, have 100 pounds and do my exam for me in the room. Like that's basically impossible. So, but anyway, I just wanted to say that I thought that's an interesting idea.
Good.
Can I comment about that in an open university context?
Sure.
We have, of course, discussed the whole question of proctored online exams with cameras and this sort of thing. And I think most of us were very wary of going down that route, not least because our student group includes a lot of people who have disabilities of one kind, including psychological and psychiatric disabilities. And the effect on them of being constantly monitored in this way might be significant. And so they're leaving aside the human rights aspects. It's likely not to find favor in the open university context. We're looking for other solutions, but we don't have an answer. I'll be quite frank.
In person, I think, is the answer, right?
But in person, so I don't know where you are, Mark, but we have students in the States, so we're never, and perhaps that would be great if the university would pay for me to go and have in-person discussions with our students in the States, but it's not likely to happen.
Yeah, I have one comment here, Hendrik, and would you like to join us and comment the camera and voice?
Yeah, sure.
Okay, please.
Well, I find it's often that if I use Stack, I see all those variants before I pose a question to the students. And sometimes I think, well, this is a trivial variant, but well, I just use it anyway. So what happens often is the students get this variant wrong because it was too easy or something like that. So the difficulty I think they will have is totally different from the thing they have. For example, we had this one question where they had to convert from Cartesian coordinates to polar coordinates. And what happened was some variants were just pure real numbers. Mm-hmm. And after they have the one with the pure real numbers, they all missed because they were thinking this must be more complicated. And so when there were difficult numbers, they had to convert and everything that were there, they had the recipe and everything went right. And where they were so easy, it just didn't work out. So I have a really big problem with the difficulty of randomized questions because they really usually are completely different than what I thought they would be.
That's very interesting. That's totally counterintuitive. You'd expect students would do better on easier questions. But what you're telling me is that, in fact, if I've understood you correctly, is that students do worse on easier questions because for various reasons, including possibly not paying so much attention. I don't know. So that's not a phenomenon I've observed myself, but I will look out for it actually now you mention it.
We had one question now with where they were supposed to find the eigenvalues of some matrices. And there were some, they were already almost diagonal matrix. No problem with that, I would think, but well, hardly anyone got it right. And then they had some with really big numbers in it. And there they were so careful working on them that everything was correct.
That's very funny. And very, yes, I can see the logic.
I get some sort of a measurement how difficult a question can be, but for some reason, students do things different than I expect them to.
Yes. Yeah, that's very interesting because I haven't looked at it from that perspective at all. I mean, perhaps it's also the case that when the numbers are relatively simple in the question, the students use mental arithmetic and are not 100% accurate, but if the numbers are big, they'll use their calculator and they tend to get things more accurate with their calculator. I don't know. So there may be various factors at work there. But as I say, it's not something I've observed and it's something I will look out for now you mention it. But it is a question, the general question of making sure that all our assessment is at the same level is important for us. Because the Open University its raison d'etre is fairness, to provide opportunities for people who haven't had the opportunities to go to university perhaps when they were younger. And so the whole basis of making sure everything is fair is an important part of our philosophy, actually. We spend a lot of time thinking about things like that.
Yeah, we have another comment here. So I encourage you to read it by Frosina, posted here. But we are actually coming to the end with today's session. And yeah, you see, it seemed at the beginning we were discussing, Ben, Chris, and I, if there would be enough questions to fill 1 hour, but it seems that now I'm in unpleasant position to say that we need to stop for at least for now. And I would like to thank you all for your participation, especially Ben, working on these very interesting questions, and all of you on. I would like to thank to this because all these points. There are many points that we starting to discuss are relevant. So yes, you're right, Fosina. It's a lovely session, and thank you all. And I wish you a very pleasant weekend, and see you next week, I hope.
Can I just ask one thing, which is, yes. I would very much like to get the chat from this session so that I can read it. I can't read at the moment.
Yeah,
could someone save it for me, please, so that I can see it? I would really appreciate that.
Yeah, Chris, I don't know if you can do it, but it will be recording available, afterwards.
Yeah, Christian will have access to it. Yeah.
Excellent. Thank you very much, and also possibly the question that was in Moodle as well.
Yeah, thank you, and bye.
Okay, bye-bye now.